Welcome. My name is Alkin, and I'd like to share some experiences with Vitess. Little bit about myself. I am a senior technical manager at PlanetScale. I am one of the maintainers for the Vitess project. I'm an open source database evangelist, previously working at Percona, Python, and some of the background in enterprise. And I'm also an avid sailor. And if you want to talk about sailing, please do find me on Instagram or Twitter. A little bit about PlanetScale, because of the relations between the Vitess project and the company is founded in 2018 by the co-creators of Vitess at YouTube, later on Google. Currently about 45 to 50 employees located in California, and it's a complete remote team due to pandemic. On the Vitess project, what is Vitess? Question can be answered by it's a database clustering system for horizontal scaling of MySQL or MariaDB databases. Why we say that it's not a database, but it's a framework that actually manages the databases that exist. So we actually take advantage of the both technologies on the framework and the database backend side. Vitess does not make any changes to the existing running databases like MySQL or MariaDB. It's a CNCF graduated project. In fact, it is one of the first database projects in CNCF, very important. That's an open source and with an Apache 2.0 license, and it has contributors from around the community with the large users of Vitess. Today's agenda is going to be an architectural overview of Vitess. I'm going to talk about what Vitess is, so you have an idea. And Vitess use cases, a little bit on sharding, and where we can actually meet MariaDB, as this is a MariaDB dev room. And thank you for inviting me over. On the Vitess architecture basics is we actually enable the database infrastructure operations to be more smooth and coming from single end. And the glossary for the terminology in the Vitess world is a key space is a logical database. Whether it's sharded or unsharded, you would actually have a key space with an ID and a primary index and a Vitess index, which points to an index. So there is a little bit of an additional terms that applies for the Vitess, which we can explain a little bit more on. The proxy server is a VT gate. A VT tablet is a backend server that actually works like a sidecar. There's also a topology data store, which can be managed by etcd, Zookeeper, or Console. Consider a common replication cluster where we have a primary and replicas. VT tablet attaches to the MySQL process in each tablet and manages the MySQL in the backend. So these coupled database structure with a replication cluster is a tablet. And in production, you would have multiple clusters, and VTGate manages them. So if we go back in time over here, each MySQL server is assigned to a VT tablet, and then each MySQL VT tablet is managed by a VTGate, where actually it's a stateless proxy. It doesn't manage, but it actually routes the traffic to the VT tablets. And you can have multiple VT gates. You're not bound to single one of them, so there's no single point of failure. Also, you can scale out the number of connections, and that points to the clusters that you have in the backend. VT gate also routes the traffic to the correct clusters depending on the sharding scheme. Since we are intending to shard our dataset using Vitess eventually, you would have to know where your data sits. So you don't have to maintain it yourself, but the Vitess maintains by VTGate. And then the queries are routed based on the schema and the sharding scheme. In this example, let's say we have a commerce database, which is a key space, and then it's sharded. There's also internal unsharded. This is important. So you don't have to shard everything, but you can still have an unsharded key spaces in your topology. And a query comes in that points to the key space, and VT gates know where that customer ID range is. Topo is another component in this architecture, actually stores the state of the schemas, shards, sharding scheme, and tablets. Can be used by etcd. We currently actually use etcd. There are others who use console or zookeeper. We don't recommend console for some reasons, but you may choose to do so. And this has a very small data set, and it's mostly cached by the VT gate. VT-CTLD is another component that's in our architecture, which is a control daemon and runs the ad hoc operations to the database, an API server, and read-writes the topo, which also operates on tablets. So these are the components of that. And then Vitess topology knows all the schemas, shards, clusters, and it keeps a state of the latest and the greatest information, because in the real production environment, these will be changing and you would need to keep them up to date as much as possible. So Vitess control plane not only includes these components, but also includes some of the normal database operations you would do. So in normal production environment, you would have some sort of a proxy server, which is covered by VT gate. You would actually have a backup and recovery, which is covered by the VT gate and VT-CTLD at Vitess using backups and recoveries. And in this case, we could actually drive extra backup for it, for different data stores. Integrated failover, that is actually known as an orchestrator, and in which case, for the Vitess topology, it is called vtorq. And sharding schemes that you can actually horizontal or vertical that you actually apply to that. There is also advanced replication options, which actually allows you to replicate from one key space to the other and vstream. There is going to be an online DDL operation, which is an experimental stage at this point, but we will be driving Ghost or Percono toolkits online schema change tools. And there's also more for that. In summary, if you have an application that's actually driving through a load balancer, you can point to VT gate, and a topology server knows your sharding scheme and points to the tablets that you have your data set. Let's go over for the supported backend delivery. This is a very popular question that is being asked in the open source community: what databases and what engines it supports. Vitess is a very MySQL centric framework, and it works perfectly fine with MySQL 5.7, and it's slowly being migrated to 8.0, and it also works on MySQL 8 compatible. And we already have very large users in the community that are heavily invested in the MySQL backend for hundreds of thousands of shards. And also it is known that it works for MariaDB for the compatibility purpose. The frequently asked question whether it will work for PostgreSQL or not, it will not work for PostgreSQL. There is going to be a need for another set of implementation that needs to be managed outside of the MySQL infrastructure. And let's talk about Vitess use cases and sharding. So in many cases, what we see is not always drop-in replacement for your entire application. In some cases, your application does only needs to scale out on certain parts, and either you have the entire application pointed to Vitess, or keep sharded and unsharded key spaces in your topology, or you just scale out where you need to. And also you can point and create a link to your existing MySQL topology and use just Vitess as your management of your MySQL topology without ever changing anything on your backend. You could do sharding and resharding. That's the key point over here. So in normal cases, once you shard, that's it. There's no actually coming back from sharding. With Vitess, since it knows how you sharded, it's able to reshard or unshard your data sets into different key spaces. And Vitess, if you scaled out with Vitess and simplified and minimized your backup and recovery scenarios by keeping a smaller data sets, this is actually a big advantage for when we see terabytes of data in a single database and having issues for both backup and recovery scenarios. There are some other use cases that you can think of, obviously, but these are the things that I just came to my mind. Where we come to the MariaDB compatibility, MariaDB, there are no extensive work has been done as far as I know, and we are looking for contributors and users. At this point, we have not received much feedback on MariaDB usage, and MariaDB compatibility for 10.4 is still pending, and there's an open issue at GitHub, and I will be following up with both MariaDB and the community, see if there's anything we can do to improve that area. So for more resources, please visit Vitess.io, and there's a user guide and docs over there. It's an open source. I can rephrase that, and it's open, and you can see the code. If you are willing to contribute, please see the contributor guide at the document. And there's also a Vitess Slack where you can actually join and create a discussion. I can create a MariaDB room if it doesn't exist, and we can discuss further on that. Let's take a look at how we can drive MariaDB through Vitess. Okay, now we're at the demo section. I have built a local Docker image. As I mentioned earlier, there are a couple of options that you can test Vitess against MariaDB. One of them is to build a Docker image. The other one is building locally, compiling from source. The third option is the Vitess operator. There's an open source Vitess operator that you can test against Minikube or your favorite Kubernetes environment like GKE. In this example, I want to demonstrate a simple use case for scaling out MariaDB database using Vitess. So the Docker image already built to save time, but I want to show you the Docker file over here, and there's going to be some dependencies installed, and we install set those dependencies per the flavor of the backend engine we use, and then build up a cluster that is example of this demonstration. And over here we also have the file for the installing local dependencies, and we use etcd for the topo server. And I will run this Docker image and build a simple e-commerce application database. So what does this do is, let's say we have an e-commerce database that is struggling to scale, and it has an order table. It keeps customer and product information for the sake of this example, and then we actually want to not only shard but also manage this environment without having to go any downtime. So basically, we're going to do a small migration over here against the schema. The initial database that is simply unsharded, and we want to experiment sharding over it. Before getting into that, I want to show you what we are running against. We are building this image against MariaDB version 10.3. And if I connect to VTGate, which in this case is our proxy for the backend instances, and take a look at the version over here. It's the MariaDB, and we are actually in the Vitess client space that actually connects. And then we have different commands over here that you're not familiar with the command line over here. If I said show Vitess tablets, it would give me an example for the cell, that is the zone, and the key space, which is the schema and the database. There's no sharding, it's unsharded. There are different tablet types. Of course, there's a primary, replica, and a read-only tablets that is attached for this cluster. So there is a little bit of an extended information over here, but basically it mimics a primary replica scenario that you would normally run in your cluster. Let's move forward with the example over here. We have some pre-set scripts over here, which you can find is under Vitess.io user guides, and there are different examples for both local install, operator, and then you can run through this scenario to experiment yourself. And I want to show you, continue on this one, showing the customer tablets. Basically, in order to get from commerce to the customer, we need to initialize a new shard. And I will run this, and then it will create new customer tablets for us, so that we can migrate our commerce database, which is unsharded, to a customer key space, which will be sharded eventually. And it's going to initialize. Basically, this is a driver of instances. As the database instance is coming up, we can connect and basically see those tablets coming up. And this operation will bring a new cluster, which is completely configured automatically in order for us to continue our example. Okay. Okay. And next up is to moving the tables to the new key space. As you can see over here from the script, I don't want to just run it so it's not hidden. VTCTL client with the move tables from commerce to customer, it will actually migrate this over to that new key space. And I will run this, and it executed already. And then next up will be moving these switching reads from commerce to customer key space. So basically, we're currently switching reads that are coming into the commerce key space into the replicas that are built for the new customer key space. Okay, and I will run this, and then a traffic switcher, which is our VTGate. VTGate actually knows about all this. Topo server keeps track of all this information, and it can actually take all the incoming traffic and migrate into the new space. Now that this will look a little bit awkward in how to visualize, we have some web interface that you can connect to. I don't want to get into that too much because we have a new VT admin UI is coming up very soon, and that is built by our contributors at Slack, and we'll be announcing that soon. Okay, let's continue with the example over here. So now that we switched reads, we want to look at switching writes. So with this command, vtctl client switch writes customer to commerce, we are going to switch the writes also, incoming writes to that. Right. So it actually, since there's no traffic, there's things are going super fast. Of course, this is not going to be the case at your example. Okay, so we have a commerce still, and at the state of serving, and then now that we switched, they're both serving, but actually all the reads and writes are going to the customer key space. So we migrated in the customer, but we did not actually, what we didn't do is we haven't sharded this space. We just prepared the topology to be able to shard. And we can actually drop sources for the customer and for the commerce, and then we can clean up the commerce space. Okay, it's going to drop the tablets, drop the tables for the from the source. Okay. So now that we want the shard, the customer space, and I want to take a look at that real quick. It is going to create a sequence for that. Now we have a concept of sequences, which it doesn't exist in our MySQL MariaDB space in too much. But the sequences are required for the auto increment values, and this way the Vitess topology server and the VT-gate can control the auto increment values that goes into these sharded environment, and then we run this. It will apply the sequences, and it will create the V schema for that, and it will apply the sharding scheme, and it will create the sharded customer space. And if we look at these, you can see these files that will actually be looking like this. It will be creating a table, customer sequence, and which is going to be Vitess sequence category. Okay, so we will be running the customer sharded. And now that we created the customer sharded environment, that is ready for our sharding. So if you look at the vSchema objects that are created, there's going to be two sequences created, one for customer, one for the order. And then the vSchema objects that are created for sharded scheme that's on hash, and the customer ID on hash, and you can change that. And then you have the column and the sequence ID. Those are attached to those values, so that Vitess knows what the sharding scheme is. Okay. The next for this example. The next one will be creating the new shards is going to be needed. All right. Let's take a look at that. It's going to create the new shards for that, and this will be the shards, and it will bring up those tablets with this. All right, and then it will initialize those shard master to the related sharding scheme. Okay. All right, it has created those tablets. Those are probably coming up. Yes, we can see the new tablets coming for the sharded customer scheme. So just to reiterate, we had a commerce key space that we actually switched over to customer, and then we started our sharding scheme against the customer key space, and then built a cluster that is that is going to be sharded against the customer. All right. So the new shards are created. All right. So now within the customer space, we need to reshard from the unsharded customer key space to a sharded customer key space. Okay. Run that example over here. All right. So we were able to reshard that. And then what we want to do is we want to switch the reads to the new sharded customer space. Okay. And we also want to switch the writes to that customer space by the traffic switcher over here. Okay. All right. Now that we have switched, the primary customer unsharded key space is no longer serving, and the switch is being made over to this. So okay, and so now we can basically get rid of that unsharded customer space and delete that. We no longer need that, and it's going to delete those tablets and free them up. Okay. And that's it. I wish we had more time to play with the data. We don't have too much data to show, and there's also a visual example of this. Again, please visit Vitess.io website under user guides. There's more comprehensive steps and implementation for this. And again, find me on Vitess Slack or Twitter or other medium to ask questions, maybe even contribute. Thank you very much for listening.